In section 6.6, we also find centers of masses, or centroids, of a few points or of a sheet, like a lamina. So if we were going to find the centroid of this sheet, we want to find its center of mass. You can imagine, firstly, just thinking about it qualitatively, that if you split the circle down the middle, the left side over here and the right side over here should have about the same size. So you'd hope that the x and y coordinates are going to match. I've written here equation 12 from your book. It's in a big box, so we can use it. We said don't memorize these, so you'll be given equations like this if we want you to find them. I'm skipping the step about the moments because I'm not asked to find them in the question that I'm working on. So, noticing that A is the area, we can find that first. Both equations need it. A is just the area under the curve. It's the integral of square root 1 minus x squared dx from 0 to 1. But we know that this symbol means the area under the curve, and that that's a quarter circle. So it's going to be 1/4 pi 1 squared, which is just pi over 4. So in both equations we already have our area. So if we want to find the center of mass, we first calculate x bar. The x-coordinate of the center of mass is going to equal 1 over the pi over 4. We'll leave it exactly the first time through, and then we'll simplify as we go, times the integral from 0 to 1 of x times the square root 1 minus x squared dx. So this looks like it could be integration by parts or substitution. As soon as you're throwing in that extra x for any function, you're probably going to need a trick. So let's let u equal 1 minus x squared. Then u of 0 is 1 minus 0, which is 1, and u of 1 is 1 minus 1, which is 0. So our limits actually swap. Du is negative 2x dx, and I don't have a 2x dx in my problem, so that gives us x dx is negative 1/2 du. So when I substitute, x bar becomes, I'm going to simplify this to 4 over pi now, the integral from u equals 1 to u equals 0 of negative 1/2 u to the 1/2 du. When I integrate that, I'm going to get u to the 3/2. I'm going to pull up my negative 1/2. I'm going to simplify and get a negative 2 over pi, because the 4 and the 2 cancel to a 2, times u to the 3/2 over 3/2, which I can multiply by the reciprocal, from u equals 1 to u equals 0. That means I plug in the upper one, so x bar is, flip the denominator and multiply, so negative 2 over pi times 2 over 3 times, now I'm going to plug in. When I plug in the 0, I get 0 to the 3/2, and when I plug in 1, I get 1 to the 3/2. So that's just a minus 1. So that makes this negative a positive. So this becomes 4 over 3 pi. So that's our x-coordinate. To find our y-coordinate, we're going to use the other equation. It's really just a matter of being able to plug the function into the equation correctly. So y bar is 1 over a, so 1 over pi over 4, times the integral from 0 to 1 of 1/2 times the function square root 1 minus x squared dx. So the squared kills the square root, which is wonderful. That gives us, factoring out our 1/2 and flipping our pi over 4, a 4 over pi times 1 over 2 times the integral from 0 to 1 of 1 minus x squared dx. So we'll integrate. Y bar is equal to 2 over pi, simplifying the 4 and the 2, times the function x minus x cubed over 3 evaluated from x equals 0 to x equals 1. Since I use substitution, I wrote the x's just to remind myself I'm not plugging in anything funny. So this is 2 over pi times, plugging in a 1, we get 1 minus 1 over 3 minus 0 minus 0 over 3. So the zeros just go away. 1 minus 1/3 is 2/3, so this equals 2 over pi times 2 over 3, which is 4 over 3 pi. And if you notice, that's the same as the x-coordinate, so it does lie directly on the nice identity diagonal. So our centroid x bar, y bar is equal to 4 over 3 pi, 4 over 3 pi. That's also rare. It's just from the symmetry of the picture. But you can see that it's just a matter of plugging in, and then it's like a Chapter 5 question, or a pair of Chapter 5 questions. Can you integrate the x times f of x, and can you integrate the f of x squared? And notice, we might be not given this, but we might be asked to find that equation, and that's perfectly fine. In one of the homework problems, you're given a linear function, and you just find what the slope and the y-intercept are so that you can find your equation. So that's nothing new. That's just being given one more step to do at the beginning. So, I hope that helps.